grade physical science. Today we're talking about physical properties, chemical properties, physical changes, and chemical changes. So first, let's start with physical change. Physical change, by my definition, is any change that does not produce a new substance. So a physical change could be a change in color, a change in size, a change in shape, a change in texture, a change in state of matter, any change that does not produce a new substance. Now, in previous classes, some of the students produced some examples, and some of those examples are shattering a vase. Okay, if you're carrying some expensive vase and you trip and the vase falls and shatters, are there any new chemical structures being formed during that time? No. It's just the material is breaking apart. That's an example of a physical change. Speaking of breaking, if you unfortunately break your arm, that's not a chemical change either. That's also a physical change. We mentioned states of matter. Changes of states of matter are physical changes. Melting ice, some would argue, well, wait a minute. At first you have ice, then you have water. Is water a new substance in that case? No. Water is still H2O, the same as ice. So as you go from ice to water to steam, all of those are also physical changes. Any questions on physical changes? Yes, Alfonso.
So steam is the same as steam and water would still be a physical change. It wouldn't be a chemical change.
If you change water to steam, that's a physical change. In order for it to be a physical change, it has to be a change. Okay? So it'd be inaccurate to say steam and water are physical changes. If you change from steam to water, that's a physical change. In both of those situations, the substance is H2O. Okay? All right, so if a physical change is any change that does not produce a new substance, what do you think a chemical change is? Harold.
It's like changing, not substances, but it produces a new substance.
Yes. A chemical change is any change that does produce a new substance. Okay? And you can only verify that at the atomic level. You can have evidence of that at the macroscopic level, but you can only definitively verify that at the atomic level. Okay? So let's see some examples of this chemical change. Rusting a nail, toasting bread. Those are a couple of classic examples of a chemical change. Okay? Rusting a nail, toasting bread. Now let's go to the next screen and let's review how rust happens. All right, you begin with a sample of iron. Now iron, pure iron is an element, right class? Yes. All right, so you have a chunk of iron right here, and you also have some H2O floating around. Okay, so what we have here is a sample of iron surrounded by H2O, commonly known as water. All right. Now, you probably already know that hydrogen and oxygen have a thing for each other. They have a strong bond. That bond is very stable. That molecule can last for thousands of years. Okay. However, even though the hydrogen-oxygen bond is strong, there's another attraction stronger, which is the attraction of the oxygen to the iron. That attraction is so strong that oxygen will break up with hydrogen and bond with iron. Okay? And that breakup doesn't happen at a random ratio. Okay? It forms a compound. It forms a compound using a set ratio. And we'll study later on in the next chapter why it forms a specific set ratio. But it forms in a ratio of 2 iron atoms for every 1 for every 3 oxygen atoms. And so it forms a substance known as Fe2O3, iron oxide. And iron oxide is commonly known as what? Rust. That's what rust is, okay? So this is 1 unit of rust right here. Now notice, y'all, this is not just a change in color. You know when iron rusts, it turns kind of oranges, right? Okay, that color change in that instance is not a physical change. What you're not seeing a substance just change color because it's mixing with some kind of color. It's an actual chemical change. This is not it can't be a physical change and chemical change at the same time. Okay, iron turning to rust is not a physical change. Iron turning to rust is a what? Chemical change. By the way, there's also a byproduct produced, which is what? The hydrogen gas, okay? And this reaction takes place kind of slowly, and so you don't see a rapid production of the hydrogen gas. It's more of a slow production of that hydrogen gas, all right? So that's one example. We also talked about organic substances, okay? You know that organic substances are made primarily of 3 elements that have combined to form a complex compound known as a carbohydrate. And so this is an example. This is not a specific example of something definite. This is just a simple example of carbons, hydrogens, and oxygen atoms bonded together. That forms organic matter. Now, organic matter, y'all, any matter that is alive, was alive, or potentially could be alive. Y'all remember that from 7th grade science? Okay? So organic matter is interesting. All organic matter is carbon-based. Now, carbon-based doesn't mean you have the element carbon inside of you. If you did an autopsy of any body, would you find a chunk of charcoal in them? No. So carbon-based doesn't mean we have the element carbon. Remember, when carbon chemically combines with other elements, it's no longer carbon, is it? What does it form?
Completely different substance.
Which in the human body's case could be your fingernails, your hair, your eyelashes, your skin, your lung tissue. Any organic substance has the atom carbon bonded with other elements. Make sense, y'all? And so if you introduce heat to any organic substance, what happens, y'all?
It moves, it changes.
What happens is the heat breaks up the bonds. And notice this stuff, the rest of the atoms begin to escape, right? They literally go up in smoke, don't they? Are y'all following me?
Yes.
And what is that carbon substance remaining? What do we call it? Ash, right? Thank you, Niall. So we call that ash. And so that's why I just taught y'all that regardless of what the matter is, if you burn organic matter, what happens to it? It turns to ash. It turns black. I just taught you why all organic substances, when you burn it, it turns black. That could be your hair. That could be a piece of chicken, a burger, paper, fish, a maggot, rat, any organic matter. Even sugar, corn, rice, any organic matter, when you burn it, you're releasing the other elements, you're breaking up those bonds, and what's remaining is the element carbon, which is black, okay? Lastly, we've talked about chemical changes versus physical changes. Let's talk about chemical properties versus physical properties, okay? A physical property is any characteristic of a material that can be observed without the material undergoing a chemical change. In other words, a physical property is any characteristic of a material that can be observed without a new substance being formed. Examples of physical properties are color, size, shape, texture, state of matter, do y'all see that any of these properties can be observed without the substance undergoing a chemical change? In other words, without the substance forming a new substance. Do y'all see that? Okay, so those are examples of physical properties. Now the other property is chemical property. A chemical property indicates whether a certain substance can undergo a certain chemical change. In other words, a chemical property can only be observed while the substance is changing into a different substance. So if the examples above are physical properties, then chemical properties wouldn't be color, size, shape, and etc. Chemical properties would be stuff like flammable. What does flammable mean?
Being able to catch on fire.
Right, able to burn. You can only tell whether something is able to burn or not if you do what? Try to burn it. That's the only way. If you try to burn it and it burns, that means the substance is changing chemically, like we said before. So that illustrates its chemical property of being flammable. If you try to burn it and it doesn't burn, then it's what?
Unflammable.
Right. Inflammable, not flammable, whatever. Okay? So that's a chemical property. How about volatile? That indicates whether it will react chemically with other substances. Okay? If a substance is volatile, if a person is volatile, what does that mean? They will easily react, right? If you call a person volatile, that means they can react easily without much. Right. Don't call a volatile person volatile. Okay? All right. Another example of a chemical property is toxic. What does toxic mean? Poisonous. Poisonous toxic means it will chemically react with your organic tissues. Make sense? Okay, that's what toxic means. So, flammable, volatile, toxic, combustible, biodegradable. Another great one is digestible. What does digestible mean? Able to be digested. Digestion is so common that we don't really think about it much, do we? If you eat a candy bar, okay, you eat chocolate in, does chocolate ever come out? A new substance comes out, doesn't it? Okay, that's a chemical change. All right? And the reason why is because a candy bar is digestible. That's the chemical property. You can only verify that chemical property if you try to eat it. If you eat a rock, what happens? A rock goes in and a rock comes out. Right, y'all? And so, which means that your body wasn't able to change the chemical structure of the rock. Okay? Okay. All right, students, great job. That concludes our lesson on chemical properties, physical properties, chemical changes, and physical changes.